Good morning, folks. My name is Dinakar. I'm a PM in the Azure data team. My focus is on Arc services. We have two Arc data services offerings, and my focus is on both of those things. So let's get started. So again, like yesterday's pattern, we'll talk about what is the Arc SQL MI, what are the benefits, what is the value proposition, why you should consider it, and how you can get started with Arc SQL MI. So I'll give a brief overview of Azure Arc, and then we'll jump straight into Arc SQL MI for the benefit of people that are joining first time today, and for some of you that haven't been here yesterday. So Azure Arc is a brand of offerings, and under Azure Arc, we have two categories of offerings. We have the Arc-enabled infrastructure and Arc-enabled services. You can think of them as the IaaS and the PaaS type of workloads. In the first one, you take care of the software, you take care of upgrades, patching, management, so you're in control. In the second model, the managed instance or the managed services is provided to you and taken care of by the provider. So that's the primary difference between the two, and we'll focus on the Arc-enabled services today. Again, just a quick overview. In the infrastructure model, we have three offerings: Arc-enabled server, Arc-enabled SQL Server, and Arc-enabled Kubernetes. The idea with all of these three offerings is that you install an Arc agent, whether it's a server or a SQL Server running in a VM, or even your own Kubernetes. Like Kubernetes can be on-prem, one of these distributions. It could be AWS, it could be GCP, it doesn't matter. You install this Arc agent on that software, on that host system, and this agent projects that resource into Azure as an Azure resource. So you'll have a Azure Server or Azure SQL Server or Azure, Arc Kubernetes, right? Arc Server, Arc SQL Server, Arc Kubernetes. And you get some benefits with this. Again, note that you're not migrating, you're not doing anything to your existing software. They just continue to run where they are. You just have this agent running next to it. And this agent will project that resource, right? So you get the inventory benefits in most of these cases. For SQL, you get additional benefits in addition to the inventory. You also get free best practice assessments that you can run against your SQL Server any number of times. You can schedule it. You get all the assessments. You can take action on it. And you can also get additional Azure services to consume against your SQL Server. Things like Defender, things like Purview. This is outside of or in addition to the basic Azure connectivity. All of these services are generally available now, ready for production. So under the data services, which is our team, we have two offerings, right? The first one is the IaaS model, which we just talked about yesterday, the Arc SQL Server, and today we'll talk about the PaaS model. In this PaaS model, we have two database engines, SQL MI and Postgres. Postgres is in public preview, SQL MI is generally available, and we'll go into in-depth on SQL MI today. So what is this Arc SQL MI or data services, and what is the value proposition here, right? So let's take a look at each of these boxes. First one is it's always current. If you look at Azure SQL MI, you get this evergreen version of SQL Server. You're not worried about what version it is. Is it 17? Is it 19? Is it 21, 22, 25? It doesn't matter to you. You're not worried about, am I still in mainstream support? Am I still in extended support? Do I have to upgrade? You don't think about all of those things, right? You get the latest updates applied to you from Microsoft, and you just take advantage of it. It's a managed instance. That's the whole point of it, right? So Arc SQL MI is exactly the same. You get these monthly updates that are given to you, and these monthly updates include both security updates and feature updates. So you don't have to worry about extended support and mainstream support or running out of support at all, right? You get this continuous in-support version, and you get the continuous innovation available to you. The second one is the as a service capability. Again, think of Azure SQL MI. You get built-in HA, you get built-in DR, you get built-in backups, right? So that's the whole point of, again, a managed offering. Like somebody's taking care of all of that for you. You don't want to take care of it, right? So again, Arc SQL MI follows the same pattern. You have built-in high availability through contained availability groups, which we just announced this week. You have built-in disaster recovery through distributed availability groups again. You have built-in backup service. So when you deploy the Arc SQL MI, and let's say you create a database, we automatically start taking backups of it. Like you don't have to do anything, no configuration, nothing. We just start taking backups of it. Because it's a cloud-like service, the billing is also a bit different here. It's a cloud-based billing, just like Azure SQL MI again. You'll see that pattern in this session. I'm comparing to Azure SQL MI. In Azure SQL MI, Microsoft owns the entire stack from hardware, software, and everything in between. So the pricing is reflective of the whole stack. In Arc SQL MI, we don't own the infrastructure. You own the infrastructure. So we only own the software part of it, the SQL Server, SQL MI, and the management capabilities. So the pricing here is reflective of what we control and what we own. But the billing model is per core model. Now, in the on-prem, the SQL Server version, you prepay for the whole just usage, right, for the whole year. In this case, you only pay for what you use, and it's per core, which means leading into the elasticity, you can scale up, scale down anytime. It's a simple AZ command. You can say AZ Arc SQL MI scale up from wherever you are to higher, allocate more CPU, or you can deallocate, right? So if you have a business where you have a predictable pattern, let's say weekends you don't have as much usage, right? You can schedule a script, Friday evening, scale it back down. Monday morning, you can scale it up. So there's a potential for cost saving here, right? Same pattern for Postgres as well. And the whole, again, bringing all of this together, the whole point of Azure Arc is to provide that unified management experience, that single pane of glass view, right? You have your SQL servers, you have your SQL MI, you have your Azure services, all Arc enabling them, the ones that are outside of Azure. You have this single Azure resource group where you can go and look at all your resources. And you have that consistent experience of viewing and maintaining these resources that are in Azure and outside of Azure. And the most important part is all of this runs on Kubernetes. You bring your own infrastructure. There is no limits or guidelines or requirements around what hardware to bring. There is no vendor lock-in here. It's fully up to you. The only thing we require is you run one of these certified Kubernetes distributions. It's called CNCF certified, Cloud Native Computing Foundation certified. Our documentation has a list of all the distributions that we support. Kubernetes is open source, right? Like it's like Wild West. There's dozens of distributions out there. And obviously we cannot go and test our software on every distribution out there. So we have prioritized the most popular ones that customers use, like Red Hat, Rancher, even Tanzu, I think, and then all the AWS, GCP, AKS, KubeADM. So all the popular ones that like 90-95% of the customers use, we test our software on that, and they are the supported versions. So you can check our documentation if you're not sure, if you're using something that you want to verify is in support. Oh, one more thing. So we also support the disconnected mode. So what that means is, when you deploy the Arc data services, and this only applies to PaaS model, not the SQL Server model. When you deploy these services, there is a connectivity parameter that you can provide. It's either connected or indirect connected. What that means is, when you deploy this in the direct connected mode, you have access to Azure. Again, you can what that means is when you create or modify your SQL Server instances on your Kubernetes cluster, your Azure will have a real-time reflection of your current infrastructure. So let's say you create a new SQL instance, you go to Azure, you can see it right away. But if you deploy this in an indirect connectivity mode, which means you're telling us that there is no direct connection to Azure. So if you go to Azure, it might not be your true reflection of your current state, because that's what you told us, like there is no connection to Azure. So the backend service that projects these resources is not working. I mean, it is there, but it's just not doing what it's supposed to do, because you said it's indirect connected mode. So we do support both connectivity modes. There are valid use cases where you want to use indirect mode. For example, if you have a spotty connection, if you're running in very remote locations or cruise industries, for example, like you're off in waters, there is no connection. The beauty of this software is that all of these capabilities are available even in the disconnected mode. And when we go into the architecture, I'll tell you how that works. But you get full HA, always current, full DR, automatic backup service, scale up, scale. All of this stuff is available to you even in the disconnected mode. So again, this is a good segue. Let me fill this out. So what are the scenarios where Arc SQL MI makes more sense, right? A lot of customers, like especially customers that have been around for a long time, they probably have their own data centers. They're just paying for electricity, right? For them to migrate to Azure, it's a huge cost. There are customers who have strategic agreements with different cloud providers. It's just the way they have to do business, right? You have to be in multiple clouds. Or you want to operate in edge locations where there is no connectivity to Azure, right? Or you have to have your applications running locally, for example, factories, right? Or you want to go to Azure, but there is no Azure data center available in your region. A lot of the like Middle East and East regions, we don't have Azure data centers in all those regions. And they have compliance requirements that the data has to stay within the country or within the borders, right? So if there is no data center, there is no option for them to migrate to Azure. But with Arc SQL MI, you can deploy Arc data services into your own local data center and still get Azure PaaS benefits, right? So that's one of the customer scenarios. So with that, let's jump into the architecture. Let me fill this slide. All right, so it looks a bit complicated, so I'll walk you through it. Let's start from the bottom right here. So you have your infrastructure. Again, there is no requirement on what infrastructure to bring. You're fully welcome to bring whatever you want. We do have guidelines on the minimum CPU, minimum memory you need to bring, but other than that, there is no requirement. So you have your infrastructure, and the first thing you have to do is install a Kubernetes cluster. Again, one of the supported distributions of Kubernetes cluster, right? Once you have your Kubernetes cluster, the first thing you do is install the Arc data controller, the one in the middle, number 2. This data controller is the control plane that provides all these built-in capabilities, right? The provisioning, deprovisioning, scale up, scale down, HA, DR, like any, actions that you perform, CRUD actions, right? You want to create a new SQL instance, you want to delete a SQL instance, you want to modify an existing SQL instance. All of these operations are handled and managed by the data controller. So remember I said all the capabilities are available in an offline mode as well. So that's managed by the data controller. So even though there is no connectivity to Azure, when you run a command to create a SQL instance, for example, or a delete SQL instance, it goes through the data controller, and this data controller or the control plane will manage that for you. Even the billing is done locally. Like we have a local backend billing service that will compute the billing. And when you are back on shore or when you connect back to Azure, that information is uploaded to Azure. You can choose to run in indirect mode forever too. There are certain things you have to do, like you lose out on certain benefits, but again, you still have the whole HADR, the whole story available to you. So after you install the data controller, then you're ready to install either the SQL Managed Instance or the Postgres. And then, so you probably know by now that the SQL MI you get is running on Kubernetes, which means it's a Linux container image. All our images are published to MCR, Microsoft Container Registry, so you can just go pull them down directly, or if you have your own private repository, you can pull it to your own repository, run your, let's say if you're a bank or a financial industry that have high security requirements, you can scan those images with your own security software, make sure it's fine and all. And then you can deploy from your repository. Like when you're deploying, you can point it to your local repository. And once you deploy the SQL MI, the tools that you use is the same. It's the same SQL Server engine, SSMS, ADS, SQL CMD, like all the familiar tools. For them, it's just another SQL Server. It's the TDS endpoint. It's the T-SQL engine. Like at that point, there is no difference for those tools. What else? Yeah, you can use AZCLI as well. And again, we also support kubectl because we are running on Kubernetes, right? We try to architect our services in a kube native way, which means for customers that are heavily into Kubernetes, they don't even have to use AZ. They can run everything through kubectl. They create a bunch of YAML files. If you want to create the data controller, SQL MI, create your YAML file, apply the YAML file, and Kubernetes will just create those resources. Any questions on this one? Okay, good. We have a lot of content to go through. So I had a similar slide yesterday where I was focused on Arc SQL Server. So in this case, again, we start from the top left. You have your workloads. If you can go to Azure, great. That's the golden path. But for the context of this discussion, you're not in Azure. You're outside of Azure, right? Either on-prem or in a different cloud. So you're outside of Azure, and for you, the choice is, am I stuck with some vendor application that requires a specific version of SQL Server, right? Or am I using one of those SSIS or SSRS type of workloads? Or am I using a Windows-only feature for SQL Server like CLR or one of those things, right? That doesn't run in Linux. If you fall into that category, or if you just don't want to migrate, like I don't have the time or resources to migrate right now, I just want to stay where I am, I want to get some benefits of Azure Arc. So that would be your path. If you're looking to modernize and get actual PaaS-like benefits, save costs and productivity because you get this built-in HA, DR, and that stuff, then you want to consider the Kubernetes-based solution. Okay, I had the same slide yesterday too. Again, it's a good, I think this is a good message to repeat so that it's clear to you what is Arc SQL Server and what is Arc SQL MI, and when do you consider both. In the first case, there is no migration. You install the agent. That agent will project your SQL Server into Azure, and you can get Purview and Defender type of services. So it's basic, I would say, level of value, but it's also proportional to the amount of effort you put in, right? You're not doing any migration. You just install the agent. In this case, there is a bit of work required upfront to get this Kubernetes thing set up. But once you get past that, you have a lot of benefit here. Right. And updates, even for the Arc agent and for the Arc data services, it's our team that's working on both of these products. So we have monthly updates. You just update the agent, or in this case, Arc data services. And I'll go through each of these like HADR in the next few minutes. Sure. Yep. Yep. Good. So the question is, if you are using SQL MI, why do you have to take care of all of these things, right? There's two parts to it. One is these benefits are provided out of the box. When I say built-in services, when you deploy SQL MI, we deploy it with HA built-in. You don't have to configure, you don't have to do anything. It's built-in. Backups, like I said, when you create the database, we automatically start taking care of it for you. The second part is, in Azure, we own the entire infrastructure and the software, right? So you don't even have to think about any of these things. What we are running in is a hybrid model where you have the infrastructure, we provide the software, right? So that's where you need to make sure there is enough storage available. You need to make sure there's enough CPU, enough memory available for these benefits to actually take effect, right? So that's where there's a joint responsibility. Yes. So the question is, how do I connect to SQL MI? Will it be any different? It's the same TDS endpoint. You can use IP address, or you can give an FQDN name, and you just connect to it. For applications, they don't even have to know anything about how it's running, where it's running, all of this stuff. It's transparent. So our team, like we are in the Arc team, right? We take the existing SQL Server container image and we add capabilities around it. So we're not doing anything to the SQL engine. We're just building capabilities around it, right? So the SQL engine is the same, whether it's running in Azure, SQL DB, SQL MI, Arc, it's the same SQL engine. There's one team that's focused on the SQL engine. Yep. So you probably saw this in Woody's session yesterday. So what I have here is a comparison of the different SQL engine capabilities and a matrix of SQL Server on-prem, Arc SQL MI in the middle, and Azure SQL MI on the right. The point here is it's the same SQL engine. There's no difference, right? Back to your question. Ignore the machine learning services, but other than that, all the enterprise features that you use today in your SQL Server is available regardless of which flavor of SQL you use, right? Where you will start seeing differences is management capabilities, right? Again, the same pattern. We have all the different management capabilities in the first column. SQL Server that you own and manage today, Arc SQL MI and Azure SQL MI. In the SQL Server world, you have to set up HA, right? 2 nodes, 5 nodes, 9 nodes, whatever nodes, right? You have to set up DR. You have to take care of the backups. You have to set up monitoring, right? So all of these things, you have to do a lot of work to get it up to a state where it's operationally ready. In Azure SQL MI, you don't even think about it. It's all built in. So we are operating in this middle hybrid space where you have the hardware, we provide the software. So we are providing the software for built-in HA, DR, and all. It's your responsibility to make sure there is enough hardware infrastructure available. Like if you want to deploy a SQL Server with built-in HA, for example, you need to make sure there is 3 times the CPU, 3 times the storage, 3 times the memory, all of that, right? You don't want to overcommit resources here. A couple of other things I'll point out is in Azure, because again, we own the whole stack, we have SLAs for availability, for throughput. In this Arc SQL MI, we cannot offer SLAs, we don't own the infrastructure. So for some of these things, we lean towards the PaaS model. For some capabilities, we lean towards the on-prem model. What else? I think one benefit I've seen is control. Like in Azure SQL MI, I think there are limits on CPU and memory that you can allocate. With Arc SQL MI, it's unlimited, right? It's like SQL Server Enterprise Edition in your own on-premises. Okay, service tiers. Again, Arc SQL MI, think of it as equivalent to Azure SQL MI. It's just running outside of Azure, right? In Azure, you have these 2 service tiers, business critical, general purpose. We have the same pattern for Arc SQL MI. General purpose is equivalent to the standard edition SQL Server in terms of limits on CPU and memory. The business critical is equivalent to the enterprise edition. There's no limits, right? A couple of other things I'll point out here. For example, high availability. I'll actually go into that in detail, but there is differences in how you get high availability, read, scale out. What else? I think those are the primary differences there. I'll go into each of these things in detail anyway, but just at a high level, when you deploy the SQL MI, you have the option to deploy it either as a general purpose or a business critical service tier. Okay, so let's look at each of these in detail. So just to give you a context, for the next few slides, I'm going to talk about HA, DR, backups, monitoring, like each of these capabilities. And I'm going to do one slide for general purpose, like how that feature works in GP, how that feature works in BC service tier. Okay, so that's the pattern for the next few slides. In general purpose, when you deploy a SQL MI, you deploy one replica, one instance of your SQL MI, which also means it can be your single point of failure, right? For example, in Kubernetes, like I don't know how many of you are familiar with it. So you have these container images that run inside a pod. And the pod is like a logical isolation of a bunch of container images. If that pod moves to different nodes, all the images move as a unit together. So the pod is that isolation. That pod runs in a namespace. Namespace is another level of isolation where you can group a bunch of pods into one namespace. And then you have the Kubernetes cluster at the bottom. Everybody knows that things happen, right? When you're running software, things crash. Software fails, hardware fails, right? How you react to it is where you have a little bit of control on. So if a pod crashes, Kubernetes is like an orchestration engine, right? It's a declarative framework where you tell Kubernetes, I want to run this pod with this compute and this capacity, and Kubernetes will go figure out the available node to run that pod on. So you don't tell Kubernetes, I want to run this pod on this node. You just tell it, I need X amount of capacity, I need Y amount of storage, and Kubernetes will try to go figure out. You can set parameters such as, I don't want these 2 pods to run on the same node. So again, Kubernetes will figure out, okay, that's the setting you want. I'll try to find 2 separate nodes where I can run your pods on. So that's how the framework works. So in this case, let's say a pod crashes for various reasons. Kubernetes, again, immediately recognizes that, and it knows this pod crashed. What it does is, oh, this pod has this container images, this much amount of CPU, this much amount of memory. It's attached to these storage classes. Let me go figure out another node where I can allocate the same pod. So it'll go find a node, one of the available nodes. It'll spin up a new pod, put the container images, configure CPU, memory, and reattach the storage to that new pod on that new node. While all this is happening, your applications are sitting and waiting, which means there is a downtime, right? So that's the point of failure, single point of failure for your Kubernetes, for your general purpose service tier. This might be okay for some read workloads where all of this process might take 2 minutes or 5 minutes, right? It might not be a big deal for certain workloads if it's just business reporting or something, right? You can wait for 5 minutes and retry, and you have your SQL Server up and running. When it comes to business critical, so it's a busy slide. So when you deploy the SQL MI, you can specify how many replicas you want as part of that deployment. You can say 1 replica, you can say 2 replicas, or you can say 3 replicas. And this is for business critical. Let's say you specify 3 replicas. So you have a primary, and we also deploy 2 secondary replicas, and we configure contained availability group as part of the deployment. So it takes about 5 to 7 minutes once you run the AZ CLI command to create the SQL MI. In that 7 minutes, or at the end of that 7 minutes, you have a 3 replica configuration with built-in high availability group with synchronous replication among the replicas all ready for you. I've worked with a lot of customers, and this takes at least 3 to 4 weeks in today's world. You go to any infrastructure team and say, hey, I need 3 VMs. I need them I need to install SQL Server on these 3 VMs, and I need to configure AG across these VMs. I need storage, I need CPU, memory. It takes at least 3 to 4 weeks turnaround time to get this set up. In this world, it's 5 minutes. So let's say, consider the same crash scenario, right? You have this primary SQL MI, you have 2 replicas, things are replicating between those 2 replicas. There is also a listener service, so your applications are connecting through that listener service to the primary replica. Let's say the pod crashes, same scenario as the previous one. In this case, the AG automatically recognizes that this primary pod has crashed. It'll go pick up one of these 2 secondary replicas and promote that to the new primary. And your listener service is automatically pointing to this new primary. For your applications, it's like a quick 1-second reconnect, and they're connecting to the new primary, and things are back up and running. While this is happening, Kubernetes still does what it's designed to do. It recognizes that, oh, this pod has crashed. So I need to go, create a new pod, find a node available, configure CPU, configure memory, attach it. So it does all of that thing in the backend. While that is happening, your applications are completely oblivious to it because they're already connecting to a new primary. So that's the beauty of this HA configuration, built-in HA configuration in Kubernetes, right? So that once that new pod comes up, it's joined back to the AG, and data is replicated, and it's brought up to date. And any questions on this one? It's the same contained AG. There's no secret sauce there. We just deploy it as one unit. Okay, so let's move to backup and restore. Again, general purpose and BC, right? So in this case, the backup and restore is exactly the same for both. There is no difference there. So you have your pod, SQL MI running. When you deploy the SQL MI, one of the parameters you have to provide is a storage class. In Kubernetes, it's all storage classes, right? In your Windows world, you have shared folders and things like that. In this world, it's storage class. So one of the parameters you provide is, what is the storage class where I should write the backups to, right? There is a requirement that the storage class has to be read-write many capable. I'll explain that in the next slide. But other than that, it's pretty simple and straightforward. The service is built in. You don't have to do anything. Once you create a database, we start taking backups automatically. So let's look at how this works in the business critical. So in the business critical, again, it's the same setup. There is nothing extra you have to do. Backups happen automatically. In the earlier slide, I said you need a read-write many capable storage class. So one of the, when you create a storage class, there are different ways you can create. There's read-only, there's write-only, there's read-write many. What that read-write many means that any pod can access this storage class. In the earlier case, where you only have one pod, if that pod crashes, Kubernetes spins up a new pod. That new pod is writing to this backup storage class. In this case, if the primary crashes, one of the secondaries is upgraded to the new primary. So this new primary should be able to continue writing to the same storage class and pick up where the old primary left. We shouldn't have to restart the backups. We should just be able to pick up and continue. So for that to happen, the storage class has to be configured as a read-write many capable storage class. Other than that, the whole the way how it works is same across both the service tiers. Backups usually happen on the primary. You can configure the backups to run on secondary. So you're offloading the backup workload to secondary. Any questions on backup? This is very similar to Azure SQL MI. Backups happen automatically. You just issue a point-in-time command, like I need to restore this database to this point in time, and then we figure out what is the latest full backup, what is the latest differential backup, what are the log backups I need to recover to get you to that point. So we do all of that for you. It's a simple, easy restore command. Okay, next, disaster recovery. So the way disaster recovery works is again similar to Azure SQL MI. If you have heard about failover groups in Azure SQL MI, it's the same concept here. The technology that's powering the failover groups is distributed AG, or distributed availability groups. So think of the left side as your, let's say, primary data center. In your primary data center, you have a SQL MI that's deployed in business critical service tier, and you have local 3 replicas. If there is a failure locally, we try to failover to one of the secondary replicas. Let's say the whole data center goes down, right? You have the exact same setup in your DR data center. You have a business critical service tier, SQL MI, again with local replicas. The primary instance in the primary data center will send the log records to the primary instance in the secondary data center, right? And these log records are forwarded to the secondary replicas. So this is, again, very similar to what we do today in the distributed availability groups. You just need to run like 2 or 3 commands to set up the distributed AG or the setup failover groups. Copy the certificates from the primary to the secondary, from secondary to the primary, and then create a failover group between the two, and that's it. It takes literally like 2 minutes to do that. Any questions on DR? Okay. Let's move on to upgrades. So if you remember earlier in the slide, I said you get an evergreen version of SQL Server. In the traditional Arc SQL Server or your SQL Server world, you have these cumulative updates that Microsoft releases, right, every month. So you have to go download it, test it, and update it, and you go through the process of that process. And then you have this mainstream support, you have this extended support. So as you approach the end of mainstream support, you're thinking of, oh, I'm going to not get any more feature updates, right? I have to upgrade. And you also have the potential of going out of support if you don't upgrade at the end of the extended support. In this model, there is no end of life, right? You just get the latest updates. We deliver monthly updates. The monthly update includes both feature updates and security updates. All you do is run AZ update command. It just pulls the latest container image. Like when we publish the monthly updates, we publish to the MCR container registry. Again, when you run the update, you just pull the latest image. In the SQL Server world, when you actually run an update, it's updating the bits locally, live, right? So there is a, depending on how big the update is, it takes a while, right? In this world, it's like a pre-packaged image. You're not going through the upgrade process. You're just swapping out the images. So the upgrade time is more predictable, more consistent, and it's very short. Any questions on this one? Yes. Yep. Mm-hmm. Yep. So first question is, can I schedule it? And second question is, can I test it? Okay, so in terms of updates, yes, you can schedule it. Again, think of how this works. In Azure SQL MI, Microsoft already does the update for you. You don't have to do anything, right? In this model, we don't own the infrastructure. We have to give you the update and you have to apply it. So you can apply whenever you want, right? You get the bits, monthly releases. One couple of things to note in updates here is we don't support skipping the updates. So if you're falling behind, let's say 3 or 4 months, you have to go through every single step. You can't just jump to the latest version. We haven't come to that point yet where for us to provide that capability, we need to have a very vast matrix of test metrics where every release we have, every monthly release, we need to be able to test on all the permutations of the previous 1 year releases. So that's a good segue to remind you. The support policy is the modern life cycle policy, which means we support up to 1 year. So you could be 1 year behind, and if you run into issues, we will support you. So for us to provide that capability of skipping the updates, we should be able to test our update to the last 12 months of releases. And we don't have the resource that big of a team to test that. So for now, you have to go through every update if you fall behind too much. The other question is, can you test it? Absolutely. You can have a test cluster, like within the same Kubernetes cluster. These days, a lot of, it's like the hypervisor, right? You can have V clusters or virtual clusters within the main cluster. So you can have a V cluster that has your production cluster, production data services, SQL MI, and you can also have your another V cluster that is your dev environment running in the same Kubernetes cluster. So you can use your test cluster to test any updates. Any other questions? Okay. Monitoring. So remember I said you have built-in high availability, built-in all that stuff, and one of the capabilities is built-in monitoring. So what we ship with Arc Data Services is the Grafana, Kibana, Elasticsearch package, the monitoring package with Arc Data Services. So what you're looking at is a Grafana dashboard. This is like out of the box. You don't have to do anything. Once you install a SQL instance, you get an endpoint for this dashboard. You open this dashboard and immediately you see this graph. The built-in monitoring pod or monitoring services starts collecting the metrics right away for all the SQL Server instances. There is a drop-down at the top where you can say, let's say you have a data controller and 5 SQL instances. You can use the same dashboard to, in the drop-down, switch across instances and see the metrics. And most of the metrics that you normally care about today, transactions per second, disk activity, CPU, memory, like all of these things are already built in. You can also upload these metrics to Azure. Remember, we talked about direct connected mode versus indirect offline mode. If you're in this direct connected mode, you can upload these metrics to Azure. You can create alerts from Azure to be notified, and then use Azure as your like log analytics workspace to dump your metrics, even your logs into Azure. So that's one of the benefits of being in that connected mode. There is also another dashboard called Kibana dashboard that has a graphical UX for logs. You'll get a similar dashboard for logs. You can search for errors and things, and you can configure alerts in these dashboards to get notified for certain alerts. Any questions? Okay. So a quick summary in terms of business continuity. You have general purpose service tier. You have your business critical service tier. Within the data center for general purpose, you have this Kubernetes provided HA solution, which means if the pod crashes, Kubernetes will create a new pod. It will do configure storage and all that stuff. So there is a potential for some downtime. In the business critical service tier, in addition to what Kubernetes provides, we have the contained availability groups as part of the deployment. So you get that multi-layer HA solution, and your applications will have near zero downtime. In terms of recovery of your data, the built-in backup service and the point-in-time restore, it's the same in both the service tiers. There is no difference there. When it comes to across the data centers, business continuity, you have the disaster recovery setup through failover groups. This feature is same for both the service tiers. You have your, let's say you are totally in general purpose. You have your primary data center, you have single replica GP SQL MI running. You have another data center, you have a single replica GP instance running. You can set up failover groups between those two. It doesn't have secondary replicas to forward the records, but you still can set up DR between those two. And then we also support long-term retention to Azure. So whatever backups we are taking, you can configure. I think there is a default setting where we just push every month or something to Azure. You just tell us where to copy those to, right? Blob container where we can copy the backup files to. Any questions? Okay, I think we are good, doing good on time. I can show you a couple of demos. How's the font? Is that better? Okay, there is a question on screen. What authentication does Microsoft use to connect to PaaS databases and take backups? That's a good question. We use a built-in service account for backups. Okay, so I just want to check what cluster I'm looking at. I'll actually show you a few things here. So as you work on Kubernetes, you'll get familiar with kubectl commands. 2 years ago, I had no knowledge of Kubernetes. So now I'm all on Kubernetes, right? So what I have is a list of the namespaces. Again, namespace is that logical isolation, which holds the bunch of pods, right? So in this case, I have Azure Arc. For data services to run in the direct connected mode, remember you have to Arc enable. Like if you think of the first category, which has the Arc enabled infrastructure, the last box was Arc enabled Kubernetes. For us to run anything in the direct connected mode or have that connection to Azure, you need to Arc enable that host system first, whether it's a Windows server or Kubernetes. So that's where this Azure Arc, when you Arc enable the Kubernetes cluster, we install that Azure Arc namespace, and we have a bunch of pods and services that run in that namespace, which provide that connectivity and being able to talk back and forth with Azure, so that from Azure you can say, I want to create a SQL instance, right, on your Kubernetes cluster. And this cluster is like in AWS, in GCP, we don't even know where it is. But this Azure Arc namespace provides that channel, that connectivity to that cluster. So we are able to go and create the SQL MI on your cluster. If you want to modify your SQL instance, or if you want to delete your SQL instance, like any of these things that you want to do from Azure portal, we need that secure channel to reach to your cluster. That's provided by this Arc agent. So our data services are in Fab NS. Let me. So if I say, give me a list of all the pods that are running in that namespace, you'll see a bunch of pods, right? So you have these first two pods that are control pods. These are the controller service that's running in the namespace. This is one of the core services that runs. Then we have built-in logs. Remember I said there is a built-in logging powered by Kibana dashboards. So there is a logs DB service, and then there is a logs UI that provides the dashboard. Then we have a bunch of pods for metrics. So there is one that is this service itself, and then we have one pod for every node that I have. So if I'm deploying on 5 nodes, there is a metrics pod running on each of these 5 nodes that's collecting the metrics locally. There is one for UX, the one that says UI. This one is powering the Grafana dashboard that we saw earlier. And then, so this is like the core data controller. Like remember in the architecture diagram, you deploy the data controller. So let's say you only deploy data controller, not the SQL or Postgres instances. Those are the pods that you will see as the core components. Once you start deploying SQL instances, that's where you'll start seeing these stuff. So for example, if I'm looking at these first 4 pods, right? SQL instance 0 and 1. So my SQL instance name is SQL instance 1. Like when I created SQL instance, I said, this is the name of my named instance. I deployed this in a business critical service tier, and I deployed 2 pods. So we suffix that with -0 and -1. And if there are 3 replicas, it will be -2 for the third one. And this is the listener service, SQL instance 1-HA-0. When you deploy the listener service, it can become a single point of failure. Like if you have multiple replicas, one pod fails, your applications are using the listener service to connect to that pod. What if the listener service fails? Right? So you have the option to say, I want multiple listener services. So if that listener service fails, your applications can use the other listener service and still connect get to the right pod. So this is where you see -0 and -1. So I have 2 listener services and 2 replicas. This is my second SQL instance where I still have 2 replicas. I only deployed 1 listener service. If I say kubectl, I need to, there you go, get SQL MI, all the SQL instances that I have on my cluster, right? So if you remember, we saw the pods. There are 2 instances. One is SQL instance 1, another is SQL MI 2. And the status is ready. I have 2 replicas in each of these. This is the listener endpoint that my applications can use to connect to. This comes into picture when you have upgrades. I'm probably already on the later version. This tells you what is the current running version. So you can see that I'm running on the January release. So the pattern we have is the version and the monthly release timestamp, year, month, date. So we have monthly releases. So there's one for February, one for March and April and so on. I think we're at 5 minutes, so I'll switch back to the presentations. Any questions? Yes. Good question. Where is this Kubernetes running? So I'm running on AKS. So actually, that's a good question. Let me show you what the Azure portal will look like. If I go to this Fabricam namespace, so you see all the resources here, right? Should I zoom in a bit? Okay, so first one I have is Kubernetes service. This is the actual AKS service. In your scenario, you will not have that because your Kubernetes service is running outside of Azure. When you Arc enable it, you will see this guy, Kubernetes-Azure Arc. So you will only see the projected resource. Then when you create the data controller, you will see this resource, Azure Arc. It's a proper Azure resource. Custom location is equivalent to the namespace. Like in your Kubernetes, when you create a namespace, we need an abstract for it in Azure. So that's the custom location. And then you have your SQL instances. Remember, I had 2 SQL instances. I can see those 2 SQL instances. I can go into those SQL instances, and then I can manage it from here, right? I can see the endpoint that I can connect to, what namespace it is in, Azure information, resource information. This is all standard from here. Any questions? Mm-hmm.
What do you think the industry would really go for this kind of architecture? Because I'm looking in a bigger picture.
Yep.
Because once you make a decision, it's a big decision for an organization to go these kind of concepts.
Yep.
Do you think there is adaptability and acceptability in the industry for those kind of things? Or for general purpose, I can say, okay, yes, that's fine. But for the business critical side of it, what is your customer feedback or usage or?
Mm-hmm. Mm-hmm. So the question is, in the industry, what is the general acceptability for these services, for this Kubernetes-based solution, right? So I work with a few customers. One of them is Royal Bank of Canada. Their case study is published online. They're a financial company, biggest bank in Canada. They have given so much feedback to us that we had to actually re-architect, redesign, redo a lot of the things that we have done because they're so super strict on security. Right? When you're asking about can I run mission critical applications, they plan to migrate all of their SQL instances to Arc SQL MI. They'll either pick general purpose or business critical depending on the application requirements. But for them, they're sold on this idea. Again, this is the same SQL MI. It's not a new SQL Server, right? It's existing SQL Server. We are packaging it with the management capabilities. It's running in your infrastructure. You control the access, you control the availability, you control the throughput. So you have full control over how it runs, who has access to it, and how fast or how slow it runs. We are just giving you the ability to manage it like we do in Azure, if that makes sense. Some resources, Arc docs, documentation are docs. I've written like 80% of the docs for Arc SQL MI. Give us feedback if you're running into any any confusion or if it's not clear. But go to docs, that's the good place to start. We have some quick start. Jump start is one example. Quick start in our docs is a good example if you want to get started. If Kubernetes is kind of limiting how to for you on how to use this, use AKS. That's what I do, right? It takes 5 minutes. Your AKS is ready. Deploy the data controller. Like you can do all of this in like 10 to 20 minutes. Like once you get through the motions of how to deploy, AKS, data controller, SQL MI, SSMS, connect to it, all ready. Okay, any questions online or are we good? Cool, sounds good. We're right on time. Thanks, everybody.